All right, so Math 3, Unit 6, Section 7, Graphing Radical Equations. We're going to look at the square root equation. Y equals square root x, that's what we'll refer to as the parent graph. If I get a table of values here, we're using a square root function, so we got to think a little bit more about what numbers we plug in for x. It's easy to take the square root of 0 or the square root of 1. But I'm probably not going to want to plug in a 2, right? Because the square root of 2 is not a nice number to graph, or a 3. And so I'd probably skip over a few x values to 4. So I'm just plugging in things where I can take the square root of perfect squares. Also, besides worrying about that, I'm also not going to plug in any negatives or numbers that would make me take the square root of a negative, because when you take the square root of a negative number, it's imaginary and you don't graph that, right? And so you're thinking a little bit more about what your domain, right? What values should I plug in to help me get an idea of this graph? When you do graph this, this particular one the domain starts at 0, because if you plug in a negative value, it's imaginary. So there is nothing to the left of the y-axis, and it increases slowly and moves to the right. And so it's as if you have a parabola, right? Parabola looks like this, and turned it on its side and only took half of that, right? This is the top half of that sideways parabola, and it's actually the same exact shape as the top half of a sideways parabola. Same idea, same types of translations that we've looked at over the past. We said when we add c and c is positive, it moves it up. If you put c at the end, subtract c, it would move it down. If we're adding c to x inside of, in this case, it'd be inside the square root, we're going to move it to the left. Subtracting would move it to the right. You put a negative in front of the square root, in this case, it's going to reflect it about the x-axis. You put a negative inside the square root, it reflects it about the y-axis. Okay. And the number in front of x, so if we had something like this, y equals a square root of x, that a can change how wide or narrow that graph is. Okay. So let's look at our first example here. We're asked to sketch the graph for each of the following and to find or solve for the indicated information. So we got two things we got to do here. First sketch, and then second, go ahead and answer A, B, C, D, E, F. Okay, so we got quite a few things to look at here. So for our sketch, we want some sense of what that parent graph looks like. Okay, so it's kind of like that sideways parabola slowly increasing to the right. But here we have a translation. We're moving, that +3 moves us left 3 units. That -1 moves us down 1. So from 0, 0, I'm going to go left 3, down 1. And that's where my graph's going to start. I'm also noticing there's a positive 1 in front of that square root, so it's going to be increasing slowly to the right. Let's get a couple other points here. So we already know that when x is at -3, we have a value at -1. And look at our square root. It's the square root of x plus 3. And remember, it's easy to take the square root of 0. And what would I have to plug in for x to make a 0 underneath that square root? -3, and so that's what we have. The next thing that's easy to take the square root of is 1. So what would I make x? X plus 3 is 1, so what would x be? -2? I'm going to plug in a -2, and I get the square root of -2 plus 3 minus 1. That gives me the square root of 1 minus 1, which is 0. So -2, 0. Let's do one more. What would be the next easiest number to plug in for x? Just think about your perfect squares. 0, 1. Next number you want to take the square root of is 4. So what should x be? 1, because we already have a plus 3 there. So I'm going to plug in a positive 1 to create a 4 underneath the square root. So I get 1 plus 3 there, which is the square root of 4. Comes out to be 1. So 1, 1. And so you have this top half of a sideways parabola here. So our domain starts at that starting point. At -3 and goes as far to the right as we want. The range, the lowest point is also that starting point, which is at a height of -1. And it slowly increases, but it will keep increasing as high as we want. So it also goes up to infinity. Our x-intercept, well, in general, to find an x-intercept, you plug in 0 for y and solve. We already have it in our graph, though. Notice we see our x-intercept is at -2. So if you already have it in your graph, you can say, well, x equals -2 is my answer. I already know that. But if we didn't have that, you'd plug in 0 for y and solve for x by adding 1 to both sides, squaring. Oops, when you square, get rid of that square root. And then subtract 3 from both sides. You end up with x is -1, which is, yes. And I was noticing something went wrong there. We square 1, we should get 1, not 2. Thank you. I was just checking. Alright, so x is -2, which is what we graphed, right, for our x-intercept. Our y-intercept, just looking at the graph, we can tell that our y-intercept's not going to be an integer. It's going to be a fraction somewhere between, or it may not even be a fraction, but a decimal somewhere between 0 and 1. And to find y-intercepts, we plug in 0 for x, and so we get f of 0 is the square root of 0 plus 3 minus 1, or the square root of 3 minus 1, which is not an easy number to come by without a calculator. So we'll just leave it that. And we see in our graph, again, it's just somewhere between 0 and 1. Part D is asking for the open interval. Remember, open interval, that word open means we're only going to use parentheses, okay, where f is increasing. And increasing means we're going, as we move from left to right, it's growing, right? So this whole thing is increasing over its domain, and so I'm just going to repeat the domain, but only with parentheses, so -3 to infinity. The open interval where f is negative. What does it mean when it says f is negative? What does it mean that a graph is negative? It means it's below what? Below the x-axis. So it starts below the x-axis and it stays below the x-axis until it gets to the x-intercept, right? And so it starts at x equals -3, and the x-intercept is at -2. So just that short little interval from -3 to -2, that's where that graph is underneath the x-axis. Okay. And lastly, the average rate of change. And when you see that average rate of change, think slope. Okay. So the average rate of change is a slope. So the slope, if we were to connect the points in a straight line from 1 to 6, let's see where 6 is. So 6 looks about right here. So from 1 to 6, so if I were to draw a straight line through those points, what would the slope of that line be? That's what it's asking. Now, ours is a curve, right? But it's saying on average, what's that slope going to be? So we need to find two coordinates. We know, well, when x is 1, what do we get for y? And we already did that in our table here, right? We plugged in a 1 and we got a 1. So 1, 1 is one of our coordinates. And the other one, we have to plug in a 6 for x. So I'll go back to our table. If we plug in a 6 for x, we get the square root of 6 plus 3 minus 1, which is 2. So I plug in a 6 for x, I get a 2 for y. And so we're going to use these 2 points to help us find our slope for our average rate of change. And remember the slope formula. Our slope is the difference of our y values divided by the difference of our x values. So I'll go 2 minus 1 over 6 minus 1, which is 1 over 5. Okay. That's your average rate of change. Question, yeah. It doesn't matter. No, as long as you are, as long as whatever you use for the first y, you match that up with the x. The x and y should come from the same coordinate pair. But whether you make it a 2 or a 1 doesn't matter. Yeah. Okay. All right, so our next example here, g of x equals 4 minus 1/2 square root of x. Again, we're asked to first sketch that graph, and then we're asked to find and solve for the indicated information. So first, let's sketch that graph. The translation on this one, underneath that square root, we're not adding or subtracting anything to x, so we're not moving left or right. It's going to be half of a parabola. Could either be the top half or the bottom half, though. Okay. This 4 right here, we could rewrite this g of x as negative 1/2 square root x plus 4. If that helps you see that, oh, okay, we're not moving left to right, but we are going to be moving up 4 units from 0, 0 to get to our starting spot. And notice there's a negative 1/2 in front of the square root of x, which means it's been reflected. So we're going to be working with the bottom half of a sideways parabola. So let's get some points here. And we need to be a little more careful because not only do we have a square root, but now we have a fraction as well. And so I could take the square root of 0, and if I take square root of 0, I get 0. And if you take half of 0, you still get 0. So 0 is a good number to work with. Because it works with both the square root and the fraction. We just get 4. And that's the first point we graphed already. Okay. We could take the square root of 1, but if I take half of 1, I end up with a fraction, right? And so I'm going to skip over that one. So you got to think about the square root, and you got to think about the fraction. So then the next thing you could take the square root of is number 4. The square root of 4 is 2, and I could take half of 2 and get an integer. So I'm going to plug in a 4 for x. And we end up with 3 as a point. So write 4, 1, 2, 3, 4 up 1, 2, 3 right here. And we see it's decreasing like we were thinking. And let's find what would be the next value for x that you can plug in to get an integer answer. 16, right? Well, if you plug in 9, you get the square root of 9, which is 3, and you have to take half of 3. So you end up with a fraction, which we could work with, right? We could work with that. But if you wanted an integer, 16 would be the next one we can plug in. And I don't even know if does it go out that far. It goes out to 14. Let's go 6. Let's try 16 then. So if I plug in a 16, we end up with 2. So it'll be a little bit out here. So about right there. So you can see it's very slowly decreasing. And moving to the right. Okay, so our domain starts at what x value? 0 and goes to infinity. And our range starts at what y value? What's the lowest it goes? The lowest it goes. It goes below 2. Because it'll keep dropping. So it'll go all the way down to negative infinity very slowly, but it will go. What's the highest this thing goes? 4. And include that 4. Okay. X-intercept. We don't. It will eventually hit the x-axis. We know the x-intercept is going to be past 16. It's slowly dropping, so we need to solve for this. So plug in 0 for y. And I'm going to subtract 4. I'm going to multiply both sides of the equation by negative 2 to get a positive 8. And I'm going to square both sides, and I get 64 is equal to x. So it doesn't hit that x-axis until you get x equals 64. So again, decreasing very slowly. Y-intercept, we see that in the graph, right? That's the first point we graphed. The y-intercept is y equals 4. And you can, if we didn't have that, you can find your y-intercept by plugging 0 in for x, which is what we did right here. And we end up with 4. So the open interval where g is decreasing, well, this thing is decreasing everywhere over its domain. And because it says open, we only use parentheses. So from 0 to infinity. So I'm copying the domain using parentheses only. And lastly, the average rate of change. What does average rate of change mean? Slope. And we know that when we plugged in a 0, we got 4. And when we plugged in a 16 for x, we got 2. So we already have our 2 points that we can use. And so for our slope, I'm going to take a y value minus a y value, and then the corresponding x value minus the corresponding x value. So we end up with 2 over negative 16, and then you reduce that to 1 over 8. So it's slowly decreasing. at that rate on average between 0 and 16. Okay, so the next one, we have h of x is 2 times the square root of x plus 4 minus 1. Same instructions. We're to first graph and then answer the following. I want you to give this one a try on your own. Okay? All right, on this one, so starting with the graph, work with that translation. We're going to the left 4 and down 1 from 0, 0. And that gives you your starting point. And because the 2 is positive, out in front of that at square root, it's going to be increasing. Okay? I'm going to get some other points here. Okay, so we already have a point at negative 4. I'm thinking about my square root. I got an x plus 4 underneath that square root. I want to take the square root of 1. So I need to plug in x equals negative 3 to create the square root of 1. So this is 2 times the square root of negative 3 plus 4 minus 1, or 2 times the square root of 1, which is what I wanted. And that comes out to be 1. So negative 3, 1. And I'm going to get one more point. I want to take the square root of 4. So I'm going to plug in a 0 for x, which makes the square root of 4. And I end up with a y value of 3. And so we have this curve, which is like the top half or of the sideways parabola here. Domain, what do you guys put for the domain? Domain goes from where to where? Negative 4 to infinity. And the range? Negative 1 is the low point, up to infinity. X-intercept, not obvious from the graph. We see that it's between negative 4 and negative 3, but it's not obvious exactly what that value is. So we need to plug in 0 for y. And solve here. I'm going to add 1 to both sides. Divide by 2. And when you square both sides, you end up with 1 over 4 is equal to x plus 4. If you want to think about in terms of graphing, it's easier to graph when you're working with decimals. So I'm going to change that 1/4 to 0.25. And then I'm going to subtract 4 from both sides of the equation. I end up with negative 3.75. And that's believable. That looks like probably where that graph is crossing the x-axis at negative 3.75. My y-intercept, that's much easier. I could see that. That happens at 0, 3. We've already graphed that point. Where is this thing decreasing? It's not, right? Nowhere. Sure. The open interval where it's positive. Okay, now positive, h is positive means above the x-axis. That's what we mean by positive. And so it starts at what point? At the x-intercept. The x-intercept is the spot where it passes from below to above, right? And so what x value is the x-intercept? Negative 3.75. And then everything past that, it stays positive, stays above the x-axis. Okay? So that's what we were after there.